Hello, today I want to discuss the potential warming of Mars as a first step in terraforming the planet. The first thing to say is that Mars is cold, very cold, with temperatures that vary from minus 133 Celsius, that's minus 207 Fahrenheit at the poles in winter, to extreme highs of 27 degrees Celsius, that's 80 Fahrenheit at the equator in summer. The planet's average temperature is overall about minus 63 Celsius, that's about minus 81 Fahrenheit. And because it orbits further from the Sun than the Earth, it receives just about 43% of the sunlight that reaches Earth. Mars had a carbon dioxide atmosphere with just 0.006 bars of atmospheric pressure, which is just a tiny fraction of Earth's. So it's not something that any of us could breathe, and neither is it something that any life on Earth could survive, particularly with the cold temperatures. It has a good deal of water ice and frozen carbon dioxide on its surface and in its polar ice caps. Both of these could serve as greenhouse gases if they were heated sufficiently to sublimate and to enter the atmosphere. A temperature rise of just 8 degrees might be enough to do this. There are potentially 3 ways that Mars might be warmed at the start of a terraforming project. The first of these is changing its albedo or reflectiveness. Mars' polar ice caps are very bright and reflect most of the sunlight which hits them. Therefore, they are said to have a high albedo or reflectiveness. Changing the surface of the ice from white to black would allow more of the sun's heat to be retained and begin to melt the ice. This could be done by impacting carbonaceous asteroids into the poles. The impact energy of these asteroids would cause more melting, increase atmospheric pressure by allowing frozen carbon dioxide to enter the atmosphere, and raise temperatures even further. The downside is that Mars' normal seasonal temperature swings results in carbon dioxide falling back onto the poles as snow. So the warming would have to be sufficient to stop that happening. Asteroids could also add more carbon dioxide to the atmosphere if they impacted carbonate rocks. However, so far these have been very hard to find. The second approach to raising Mars' surface temperature that has been suggested is by the use of giant space mirrors. These would have to be many miles across and has been suggested as a way to increase the amount of sunlight reaching the surface of Mars. The mirror would have to be placed in a polar orbit around Mars so that it was always in the light and facing the Sun. This should reflect over 70% of the sunlight it receives onto Mars' surface. However, mirrors might need to be constantly adjusted to maximize their effectiveness. A mirror could also be placed in a stable Lagrange point on the far side of Mars, where the Sun's gravity and Mars's gravity equal each other out. It could stay there and would require less adjustment to keep it in place. However, it would have to be even larger to extend beyond Mars' shadow. Currently, we have little idea how we would build such a structure. It might be possible in our far future to convert a metal-rich asteroid or one of Mars' small moons into a mirror, but this is just conjecture at this point. The next approach would use artificially produced greenhouse gases, which are far more effective than carbon dioxide at producing warming. They're transparent to incoming sunlight, but serve as a thermal blanket, stopping some of the sun's heat radiating back into space from the surface. Although they would initially have to be produced chemically, later genetically engineered microorganisms could produce these gases, protected from low temperatures by a greenhouse or a layer of plastic on the surface or a sprayed aerogel layer on the ground. CFCs, chlorofluorocarbons, have been suggested as appropriate and effective greenhouse gases. They're about 10,000 times more effective at warming than carbon dioxide as greenhouse gases, but unfortunately they destroy ozone, which protects the surface and potentially people from dangerous radiation. Fortunately, there is another group of greenhouse gases called PFCs, perfluorocarbons, which don't contain chlorine and therefore don't damage the ozone. Instead, they use fluorine, which has been found on Mars, on the surface. PFCs have very long lifetimes, as long as 50,000 years, which means that they could continue to help warm Mars for thousands of years after they're introduced. They're also more resistant to being broken down by ultraviolet radiation than CFCs are. Even if all the frozen carbon dioxide on Mars' surface were added to the atmosphere, this would probably only build an atmosphere with a surface pressure of about 0.15 bars, about 1/7 of Earth's surface pressure at sea level. This isn't enough to build an atmosphere that would allow plants and animals to survive. Therefore, more oxygen and nitrogen would have to be imported from elsewhere in the solar system to make Mars ready for life. There have been other suggestions as to how we could warm Mars, and probably the principal one of these is by using nuclear blasts, using nuclear weapons. They have been suggested as a way to warm and to melt, sublimate the ice caps. However, they might require as many as 10 million nuclear blasts and would contaminate the surface with radioactive elements like uranium. The other point that stops this is that space law currently prohibits the use of nuclear weapons in space. So that's probably not a feasible way to warm Mars. So in summary, it will probably be a combination of different approaches that will be needed to produce sufficient warming to make Mars ready for life. But the costs and technical complexity of this might mean it takes a long time to take place and probably won't start for many hundreds of years anyway. Anyway, thanks for listening today.